Let's take a look at this word problem. Identify the initial value in each case, or the y-intercept. Check out the rate of change for each situation, and then write an equation for each situation. Once we do that, we're going to take the next step and graph the equation for each marina. Let's take a look at the story. The Cala Marina charges $20 for a rental fee for a boat, in addition to charging $4 an hour for usage. The Shuver Marina charges an $8 rental fee for a boat, in addition to charging $8 an hour for usage. Write an equation for each that represents X, the number of hours, and Y, the total cost. Let's start with the initial value for the Cala Marina. You know we have to put up $20 as a rental fee. But for the Shuver Marina, we only have to start with an initial value of $8 for a rental fee. Now, your hourly rate for Cala Marina, that marina will charge you $4 per 1 hour. But the Shuver Marina is a bit more expensive when it comes to the hourly rate. That marina will charge you $8 per every 1 hour. We know if we take 4 divided by 1, we get 4. And if we take 8 divided by 1, we get 8. Now let's write an equation for each marina. For the Cala Marina, we know we have to follow the basic format mx plus b equals y. Well, our slope is $4 times every hour x plus a $20 rental fee equals y. And for the Shuver Marina, we need to use the same format, but this time it's $8 times every hour x plus an $8 initial rental fee, that's our y-intercept, equals y. But the real question is here, now that we've written an equation for each marina, which is the better buy? Which is the better deal? Well, depending on how many hours you're out on the lake, that will determine which is a better buy. And one way to make a clear comparison is to graph each equation. Let's look at our graph at the bottom and chart each equation. Let's take a look at the x-axis first. That represents the number of hours x that you are out on the lake. And the y-axis, well, that represents the cost in dollars. Let's first graph the Cala equation. We see our initial start value is 20. That's our y-intercept, and it's located here. We are going to increase at a rate of $4 per every 1 hour. As we climb, I hope you notice that we go from 20 to 24. That's our $4 increase. So up $4 over 1 hour. There's our next solution, 1 hour, $24. Again, up 4 over 1, $2 or 2 hours, we owe $28. and the pattern continues. Take this particular pattern all the way to the edge of the graph. All of those solutions form a lovely line. We're going to grab our ruler and connect up that group of solutions, and we're going to label it with the equation, and I'll even add Callan. Now let's plot the information for Schuver. We know that for Schuver we started $8 right here. Initially, that fee is cheaper than Callan's Marina. However, the hourly rate, it's $8 per every 1 hour. This is going to climb much more rapidly. So, with your pencil point on the 8, go up 2 blocks. That represents the $8 climb from 8 to 16 over 1 hour. Again, up 2 over 1, up 2 over 1, and yes, they share a point, up 2 over 1, up 2 over 1, and continue to the edge of the graph. Grab your ruler and connect the dots. As you can see, there is one point shared by both marinas. For 3 hours, both marinas would charge you $32. That point of intersection is shared, and it is the one common point that we have for both lines. You can see that it's cheaper in the beginning for the first hour and the second hour to book with the Schuver Marina. However, if you're going to be out on the lake for a longer period of time, you can see that Callan is cheaper right here for 4 hours, 5 hours, 6 hours, and so on. That marina will be a little less expensive. This concludes this video.